Something is moving right now. Not near you. Not in this room. Not on this planet. Something is moving far away. Very far away. Further than your mind can easily reach tonight. It has been moving for over 40 years. It has never stopped. It has never slowed down in any meaningful way. It is about the size of a large car. It weighs less than a ton. And it is, at this precise moment, the most distant object that human beings have ever placed into space. Its name is Voyager 1. And while you're settling in, while you're getting comfortable, while the rest of the world outside your window continues its ordinary business, Voyager 1 is out there, drifting, silently, through a darkness that has no equal on Earth. Take a breath, slow and easy. There is no rush here. Before we go any further, I want to ask you something. Where are you right now as you listen to this? Are you at home, lying in bed, with the lights already off? Is there a blanket pulled up around you? Maybe the room is quiet, and the only sound is this voice. Or maybe you are somewhere else entirely. A late evening on a sofa, a long journey, a night that has gone on a little too long, and you need something gentle to carry you towards sleep. Wherever you are, I am glad you are here, and I want you to know that this story is made for exactly this moment, for the quiet, for the stillness, for that space between being awake and drifting off, where the mind is soft and open and ready to receive something slow and something vast. Because that is exactly what this story is, slow and vast. Tonight we're going to follow Voyager 1, not just to where it is now, not just through the next few years or the next century. We're going to follow it much further than that. We're going to trace its journey across the next 10 trillion years, a number so large that it barely feels like a number at all, a span of time so deep that the universe itself will look completely different by the end of it. But we are going to start simply, calmly, one small step at a time. So, let us begin. The year is 1977. The month is September. The place is Florida, on the eastern coast of the United States. It is early morning. The sky is pale. The air is warm. And a rocket is sitting on a launch pad at Cape Canaveral, pointed upward toward the sky. Attached to that rocket is a spacecraft, a machine about the size of a small family car, covered in gold-coloured insulation, carrying a large dish antenna pointing outward, ready to send signals back to Earth from wherever it ends up going. At this point in history, the world is very different from today. There are no smartphones. There is no internet in any form that most people would recognise. The engineers who designed this mission did their calculations by hand, or with early computers that were far less powerful than the phone in your pocket. And yet, these people are about to do something remarkable. They're about to send a machine into space on a path that will eventually carry it out of the solar system entirely. The launch goes well. The rocket climbs, the spacecraft separates cleanly, and Voyager 1 begins its journey, quiet, steady, already moving faster than almost anything else humanity has ever built. Nobody alive on that September morning could have fully imagined what that moment meant. Not really. Because the journey that begins on that day is not a journey that ends in a human lifetime. It is not even a journey that ends in the lifetime of human civilization. It is a journey measured in timescales so enormous that they make all of recorded history seem like the blink of an eye. Tonight we follow that journey together, gently, without rushing, one piece at a time. Let us pause here and make sure everything is clear. Because before we go any further forward in time, it helps to understand a few very simple things. What Voyager 1 actually is, what it was sent to do, and why, after all these decades, it still matters. Start with this. Voyager 1 is a space probe, A space probe is essentially a robotic spacecraft with no crew aboard. It carries scientific instruments instead of people. Cameras, sensors, devices that measure temperature, radiation, magnetic fields, and the density of particles in space. These instruments send data back to Earth in the form of radio signals, and scientists on the ground receive those signals and use them to learn about places that no human being has ever visited directly. Voyager 1 was designed to do one specific thing first: visit the outer planets, Jupiter and Saturn specifically. These are two of the largest planets in our solar system, and in 1977 we knew surprisingly little about them in detail. We had seen them through telescopes for centuries, but we had never had a close look, never seen their moons up close, never measured their magnetic environments directly. So Voyager 1 flew toward Jupiter first. It arrived in 1979, roughly 2 years after launch, and what it found was astonishing. Jupiter is not just a large ball of gas. It is a world of violent storms and swirling clouds and enormous magnetic fields. Its moon Io turned out to have active volcanoes, the first time active volcanoes had ever been found anywhere other than Earth. Another moon, Europa, appeared to have a crust of ice covering what might be a liquid ocean beneath the surface. These were discoveries that genuinely surprised people. That changed the way scientists thought about where life might exist in the universe. After Jupiter, Voyager 1 continued on to Saturn. It arrived in 1980. Saturn's rings, which had always appeared as a simple flat disk through telescopes, turned out to be extraordinarily complex up close. Thousands of individual ringlets, gaps and waves and structures shaped by the gravitational pull of Saturn's many moons. And Saturn itself, like Jupiter, turned out to be far more dynamic and detailed than anyone had previously imagined. By the time Voyager 1 had finished its encounters with Saturn, its primary scientific mission was essentially complete. It had done what it was sent to do. But here is the thing, it was still moving. It was still sending signals back to Earth. And the people at NASA made a decision. They would keep listening, keep tracking, keep receiving whatever data the spacecraft could still transmit. Because even though the original mission was over, Voyager 1 was going somewhere that no machine had ever gone before, and it seemed foolish not to pay attention. So the mission continued, quietly, year after year. The spacecraft kept moving outward, away from the sun, away from the planets, deeper into the outer solar system. Its instruments continued measuring the environment around it. Its antenna continued pointing back toward Earth. And slowly, over the following decades, it became clear that Voyager 1 was going to do something remarkable. Something that had never been done before in the history of human exploration. It was going to leave the solar system entirely. Now. Here is a simple way to understand what that means. Think of the solar system as a kind of bubble. The sun sits in the center of this bubble, and it constantly releases a stream of particles and energy in all directions. This stream is called the solar wind. It flows outward from the sun at high speed, pushing through space, and it creates a kind of boundary, a region within which the sun's influence dominates everything around it. Scientists call this region the heliosphere. Inside the heliosphere, the environment is shaped primarily by our sun. Outside the heliosphere, you're in what astronomers call interstellar space. That is the space between the stars, a place where the sun's presence is barely felt at all. In 2012, after 35 years of continuous travel, Voyager 1 crossed that boundary. It left the heliosphere. It entered interstellar space, and it became the first human-made object in history to do so. That is where Voyager 1 is tonight, drifting through interstellar space, moving steadily, silently, through a darkness that makes the space between planets seem almost cozy by comparison. and its journey has barely begun. Let us think about distance for a moment. Really think about it. Not just say the numbers out loud, but try, gently, to feel what they mean. You already know that Voyager 1 is far away, more than 23 billion kilometers from the Sun. That number has come up already. But numbers like that tend to slide off the mind without leaving much of an impression. They're too large for our everyday experience to grip. So let us try something different. Let us try to build the distance slowly, starting from something familiar. You're lying down right now, or sitting, close to the ground, close to the surface of a planet that is, itself, about 12,000 kilometers wide. That is the Earth. The whole Earth. 12,000 kilometers from one side to the other. The Moon is roughly 30 times that distance away from us, about 380,000 kilometers. If you drove a car at highway speed without stopping, it would take you about 5 months to reach the Moon. That already feels like a long way. And for most of human history, the Moon was the most distant place anyone had ever seriously considered visiting. The Sun is much further, about 150 million kilometers from Earth. That same car journey, at the same speed, would take you about 170 years to complete. The Sun is so far away that even light, the fastest thing in the universe, takes about 8 minutes to travel from the Sun's surface to our eyes. When you look at the Sun, you're not seeing it as it is right now. You're seeing it as it was 8 minutes ago. Now keep going. Keep stretching. Jupiter, the first major destination of Voyager 1, is roughly 5 times further from the Sun than Earth is. Saturn, the second, is about 10 times further. These numbers grow quickly. Each step outward takes you further than the last. And Voyager 1, right now, is more than 150 times the Earth-Sun distance away from the Sun. That same light that takes 8 minutes to reach Earth from the Sun. It takes more than 20 hours to travel from the Sun to Voyager 1. 20 hours of light-speed travel just to cover the distance. When scientists want to communicate with Voyager 1, they send a radio signal from an antenna on Earth. That signal travels at the speed of light, and it takes more than 20 hours to reach the spacecraft. Then Voyager 1 sends a signal back, and that signal takes another 20 hours to return. So a simple two-way exchange, a question and an answer, takes nearly 2 days just because of the distance. And yet, despite all of that, despite being more than 23 billion kilometers away, despite being the most distant object humans have ever placed in space, Voyager 1 is still, in the context of the wider universe, almost impossibly close to home. Here is why. The nearest star to our Sun is a small star called Proxima Centauri. It is approximately 4.2 light-years away. A light-year is the distance that light travels in one full year. Light moves at about 300,000 kilometers per second. In 1 year, it covers roughly 9.5 trillion kilometers, so 4.2 light-years is about 40 trillion kilometers. That is the distance to the nearest star. Voyager 1 has travelled about 23 billion kilometers. The nearest star is about 40 trillion kilometers away. That means Voyager 1 has covered roughly 1/2000th of the distance to our closest stellar neighbour, after over 40 years of continuous travel, moving faster than a bullet, without stopping, without slowing, 1/2000th of the way. At its current speed, Voyager 1 would need approximately 73,000 years to reach Proxima Centauri. If it were heading in that direction, which it is not, it is heading somewhere else entirely, but even so, the number gives you a sense of what we're dealing with. The universe is not just large, it is large in a way that resists comprehension, in a way that makes our ordinary sense of scale feel almost laughably small. And Voyager 1, tiny and distant as it is our first small attempt to reach into that vastness. Our first physical object sent out beyond the solar system's edge and into the wider galaxy. There is something both humbling and quietly beautiful about that. A machine the size of a car, built by people using tools that would seem ancient today, carrying a small nuclear power source, a few scientific instruments, and an antenna pointed back toward a planet it will never see again up close. Moving, always moving, through a silence that has no end. Let your breath slow down a little. Let your body settle. The night is long, and the story ahead of us is longer still. We are only just beginning to understand the scale of what Voyager 1 is actually doing, and where, across the unimaginable stretches of time ahead, it is going to go. By now, you have a picture. A small spacecraft launched in 1977, visiting Jupiter and Saturn, crossing the edge of the solar system in 2012, drifting now through interstellar space at 60,000 kilometers per hour, more than 23 billion kilometers from home, still moving, still transmitting, still being listened to by a team of scientists on Earth who have dedicated years of their lives to staying in contact with it. That picture is real. Every detail of it is accurate. And it is already remarkable enough on its own terms. But here is where the story takes a turn. Here is where it becomes something different from a simple account of a space mission. Because the question we are really here to explore tonight is not where Voyager 1 has been. It is where Voyager 1 is going. Not over the next few years, not over the next few centuries, but over spans of time so enormous that they make all of recorded human history feel like a single breath. The title of this story mentions 10 trillion years. That number deserves a moment of attention before we continue, because it is not like other large numbers. It is not the kind of large that you can simply accept and move on from. It requires a small adjustment in how you think about time itself. 100 years is a long human life. 1,000 years takes you back to medieval castles and Viking longships. 10,000 years takes you back before written language. 100,000 years takes you to early modern humans, just beginning to spread across the planet. 1,000,000 years takes you back to a world before our species existed in its current form. 1,000,000,000 years. That is when the first complex multicellular life was beginning to emerge on Earth. The planet was already ancient. The sun was already burning, but the world looked nothing like it does today. And 10 trillion years. 10 trillion is 10,000 billion. It is a number so far beyond our current age of the universe that the universe itself, which is currently about 13.8 billion years old, would need to grow nearly 1,000 times older just to reach it. At 10 trillion years from now, the universe will be in a state that physicists sometimes call the stelliferous era, drawing toward its close. The age when stars burn and shine and warm the space around them will be coming to an end. The last small stars will be cooling. The galaxies themselves will be changing in ways that are difficult to fully predict. And Voyager 1, if nothing disturbs it, if nothing intercepts it, if the laws of physics continue to hold as they currently appear to hold, will still be moving. This is the journey we're going to trace together tonight. Slowly, gently, one era at a time. And the deeper we go into it, the more the story changes from a story about a spacecraft into something larger. A story about the universe itself, about time, about what it means for something human to persist in a cosmos that does not especially care whether anything persists at all. But we will not rush any of that. There is no need to rush. The universe is patient, and so are we. For now, settle a little more deeply into wherever you are. Let the weight of your body feel heavier. Let your breathing find its own quiet rhythm. The next part of this story begins where Voyager 1 is right now, in the dark, in the cold, in the extraordinary silence of interstellar space. moving steadily outward into a galaxy that contains more stars than there are grains of sand on every beach on Earth. Something very small, going somewhere very far, for a very, very long time. Interstellar space has a texture to it. Not a physical texture you could feel with your hands, but a quality, a character, something that makes it distinct from the emptiness people usually imagine when they think of outer space. Most people picture space as simply nothing, a void, a blank, and in some ways that picture is not entirely wrong, but it is incomplete. Scientists call it the interstellar medium, a thin, diffuse mixture of gas and dust that fills the spaces between stars. Its density is extraordinarily low. On average, in the region where Voyager 1 currently travels, there is roughly 1 atom per cubic centimetre of space. 1 single atom. In a cube about the size of a sugar cube. The air in the room where you're lying right now contains approximately 27 million trillion molecules per cubic centimetre. The comparison is almost incomprehensible, and yet Voyager 1 moves through this medium. It does not feel it. There is no friction in any meaningful sense. The particles are far too sparse, but the spacecraft's instruments can detect them, can measure their presence, and send that data back to Earth as faint radio signals that take more than 20 hours to arrive. The temperature of the interstellar medium varies considerably. Some regions are very cold, close to minus 270 degrees Celsius, just a few degrees above absolute zero. In these regions, atoms move barely at all. Everything is as still and slow as matter can possibly be. Scientists believe the solar system sits within a structure called the local bubble, a large region of space carved out by a series of supernova explosions that occurred millions of years ago. The supernovas blasted material outward, leaving behind a cavity of hot, thin gas. Our Sun, and Voyager 1 along with it, drift slowly through this bubble. There is something calming about imagining that, a bubble of slightly warmer space, formed by the deaths of ancient stars, and just beyond the edge of our solar system's own protective envelope, a small metal spacecraft. Moving through the remnants of explosions that happened before our species existed. Voyager 1 does not observe the interstellar medium the way a traveller observes a landscape. It simply moves through it, its instruments measuring, its antenna pointing homeward, its nuclear power source slowly converting heat into the small amounts of electricity needed to keep the systems alive. But we can observe it from here, from this warm, quiet place where you're resting. We can follow its path with our minds. Imagine what surrounds it. Hold the image of this small, silent machine moving through an ancient and enormous darkness. Breathe slowly. The story continues, and the distances ahead grow longer still. There is something aboard Voyager 1 that we have not talked about yet. Something that changes the nature of this story in a quiet but important way. Attached to the outside of the spacecraft is a disc. A 12-inch gold-plated copper disc sealed in a protective aluminum cover. It looks, at first glance, something like a vinyl record. But this disc is not simply a record in the ordinary sense. It is something more deliberate, more thoughtful, more strange. It is called the Golden Record. It was created in 1977, before Voyager 1 launched. Put together by a small team of scientists, artists and thinkers, led by the astronomer Carl Sagan. Their task was unusual. Choose sounds and images and information that might represent life on Earth. Create something that could, in theory, be found by another intelligence somewhere in the galaxy and understood as a message from the beings who built it. The record contains sounds, natural sounds from Earth, wind, rain, surf against a shore, thunder, the singing of birds, the calls of whales, the sound of a mother kissing her child, a human heartbeat. It contains music, Bach, Beethoven, a Navajo night chant, a Peruvian wedding song, music from Japan, from India, from Senegal, a Chuck Berry song. Pieces chosen to gesture toward the breadth of human musical expression. It contains spoken greetings in 55 different languages, simple phrases, warm phrases, hello, we're here, we hope you're well, and it contains images. 116 photographs, encoded as analog signals, images of the solar system, of Earth from space, of landscapes and oceans, of human beings at different ages, of animals and plants, of a nursing mother, of a child learning. The chance that any other intelligence will ever find the golden record is, by any honest calculation, extraordinarily small. Voyager 1 is not heading toward any particular star. It will drift through interstellar space for millions of years before coming anywhere near another stellar system. Carl Sagan and his team knew this. They were not naive, but they made the record anyway, because the act of making it mattered, because deciding what to put on a record for the universe forces you to think about what life on Earth actually is, stripped of all the ordinary noise and distraction. The golden record is still out there tonight, sealed in its aluminum case, attached to a spacecraft more than 23 billion kilometers away, carrying whale song and back and the sound of rain and a human heartbeat, moving away from us at 60,000 kilometers per hour into a darkness that has no edge. We sent our music into the stars, we sent the sound of our oceans, we sent a heartbeat, and somewhere out there, that heartbeat is still travelling. There is a practical question that sits quietly beneath all of this wonder, a question that matters enormously if you want to understand the full shape of Voyager 1's journey. And the question is simply this: how does it stay on? How does a spacecraft launched in 1977, now more than 23 billion kilometers from the nearest power source, continue to function, continue to send signals, continue to maintain any contact at all with the people back on Earth who built it? The answer involves a technology called a radioisotope thermoelectric generator. The name is long and technical, but the underlying idea is beautifully simple. Inside the spacecraft there is a small amount of a radioactive material called plutonium-238. This particular form of plutonium is not the kind used in nuclear weapons. It is a different variety, one that decays slowly and steadily, releasing heat as it does so. That heat is then converted directly into electricity using devices called thermocouples. No moving parts, no combustion, no solar panels, just the steady, quiet decay of atoms, releasing energy, turned into the small but sufficient amounts of electricity that keep Voyager 1 alive. When Voyager 1 launched, its power system was generating roughly 470 watts, less than 5 old-fashioned light bulbs, but enough to power the spacecraft's systems, instruments, and transmitter. The problem is that plutonium-238 decays over time. Its half-life, the time it takes for half of the material to break down, is about 88 years. After 88 years, the power output drops to roughly half. After another 88 years, it drops to half again. Voyager 1 has been in space for over 47 years now. Its power output has declined significantly. Scientists estimate it is currently generating somewhere around 250 watts or less, and that number continues to fall, slowly but inevitably, every single year. This means NASA engineers have had to carefully decide which instruments to keep running and which to switch off. Various systems have been powered down to conserve energy. Each decision buys a little more time, a little more signal, a little more connection between this small machine and the people who made it. But the power will eventually run out, sometime around 2025 to 2030, perhaps a little later. Voyager 1 will no longer have enough electricity to operate any of its instruments meaningfully, and not long after that it will lose the ability to transmit signals back to Earth at all. When that happens, the connection will end. Not with a dramatic failure, not with an explosion, just a gradual fading, a signal growing weaker, and then one day silence, and Voyager 1 will continue on alone, no longer transmitting, no longer in contact, moving through interstellar space in complete and permanent silence, carrying its instruments and its golden record into a darkness it will never leave. Let that image settle for a moment. A machine going quiet, still moving, still carrying its cargo of human sound and image and thought, but no longer able to tell us where it is. Moving forward anyway, because it has no other choice. Let us move forward now, past the point where the signal fades, past the last transmission, past the moment when the engineers close their notebooks and the long vigil ends. Voyager 1 is on its own. The Earth has continued its quiet life behind it. Seasons have turned, centuries have passed. But Voyager 1 does not know any of this. It simply moves, 60,000 kilometers per hour, steady, unchanging, through the cold, thin medium of interstellar space. In the first few thousand years after the signal is lost, very little changes for the spacecraft itself. No planets nearby to disturb it, no stars close enough to exert any meaningful gravitational influence, the interstellar medium too sparse to create any friction, and so it simply continues, moving in an almost perfectly straight line through a space that offers nothing to slow it down. Over the next 10,000 years, Voyager 1 will travel an additional distance of roughly 6 trillion kilometers. That sounds enormous, and by any human standard, it is. But remember the scale we established earlier. The nearest star is about 40 trillion kilometers away. In 10,000 years, Voyager 1 will cover less than 1/5 of the distance to even the closest stellar neighbor. In 10,000 years, the world it left behind will be unrecognizable. The languages spoken on Earth will have changed beyond recognition. The stars visible to the naked eye will have shifted very slightly in their positions. The night sky will look almost the same, but not quite. None of that will affect Voyager 1. It will not know, it will not care, it will simply continue. And here is something worth understanding about this phase of the journey. For these first few thousand years, the story of Voyager 1 is essentially a story of nothing happening. Not nothing in a disappointing sense, but nothing in a profound sense. A deep, patient, almost meditative nothing. The spacecraft moves through space that is essentially identical from one millennium to the next. This is one of the most important things to grasp about interstellar travel. The distances are not just large. They are large in a way that makes time itself seem to stretch. A journey measured in tens of thousands of years through a space that changes almost imperceptibly. No landmarks, no milestones, no way to mark progress except by measuring the growing distance from a star that is, by now, too faint to see. Voyager 1 is simply in the galaxy now, moving through it the way a leaf moves through a very large, very still body of water, slowly, with no destination, subject to forces so gentle and so gradual that they will not significantly alter its course for a very long time, and yet the journey is real. The motion is real, something small and human, moving through something vast and ancient, carrying the sound of our oceans and the music of our orchestras and the greeting words of 55 languages into a silence that receives all of it without comment. Let yourself rest a little more deeply now. The story is settling into its long middle passage. But for now, just motion. Just the quiet, unceasing movement of one small thing through an enormous and patient universe. Something is about to change. Not soon, not by any human measure of soon. But on the timescale we're now moving through, what comes next is almost an event, almost a moment of contact. In approximately 40,000 years from now, Voyager 1 will pass relatively close to a star. Not close in the way we usually mean that word. Not close enough for any gravitational interaction of significance, but close by interstellar standards. Close enough to matter as a landmark in this story. The star is called AC plus 793888, a small, dim, reddish star, a type known as a red dwarf, and in roughly 40,000 years, Voyager 1 will pass within approximately 1.6 light-years of it. 1.6 light-years is still an enormous distance. More than 15 trillion kilometers. The encounter involves no contact in any physical sense, no interaction. The spacecraft will simply pass through a region of space that is marginally less empty than most interstellar space. But there is something significant about this moment. Even so, it is the first time in the entire voyage that the spacecraft will come close to any star other than the Sun. After 40,000 years of travelling through space where no star is meaningfully nearby, it will pass through the outer gravitational neighbourhood of another sun. Red dwarf stars like this one are the most common type of star in the galaxy. They are small, they burn cool and dim, and they live for an extraordinarily long time. While a star like our Sun has a lifespan of roughly 10 billion years, a small red dwarf may continue burning for 1 trillion years or more, the most durable form of stellar object that nature produces. As Voyager 1 drifts past this first stellar neighbour, something interesting is worth imagining. The star exists now, tonight, as you listen. It is out there, burning its quiet red light across the void. In 40,000 years, Voyager 1 will drift through the outer darkness that surrounds it, moving past at 60,000 kilometers per hour, without slowing, without noticing, without any ceremony at all, and then it will continue into the next stretch of emptiness. There is a deep quietness to this part of the story, a slowness that mirrors the slowness of the universe itself at these scales. We're used to stories that have events, turning points, moments of action. But Voyager 1's journey, at this stage, is almost entirely empty of events in that ordinary sense. It is a story of motion and distance and time, and there is something about that which feels, if you allow yourself to sit with it, almost peaceful. The idea that something can simply continue, simply move, simply be present in the universe, doing nothing dramatic, requiring nothing of the space around it, and yet persisting. Century after century, millennium after millennium. The universe does not hurry. Voyager 1 does not hurry. And perhaps, for just a little while tonight, we do not need to hurry either. Let your body become heavier. Let the thoughts that were still moving begin to slow. Something ancient by then. Something that was once new and full of human intention. Now simply a traveller. A small, cold, quiet traveller in a very large and very patient universe. We need to make a shift now. A shift in how we think about time itself. Because the scale we are moving into next requires a different kind of patience. Up until now, we have been thinking in thousands of years, 10,000, 40,000, numbers that are large by human standards but still somehow connected to human history. 10,000 years ago, people were building early settlements. 40,000 years ago, our ancestors were painting caves. But now we move into millions of years. And millions of years is a different kind of number entirely. 1 million years ago, our direct ancestors used stone tools and had fire. They were unmistakably human in many ways, but they would not have understood a single word of any language spoken on Earth today. 5 million years ago, The lineage that would eventually become humans had only recently separated from the lineage that would become chimpanzees. These are the depths of time we're now entering, and Voyager 1, moving at its steady 60,000 kilometers per hour, will drift through this entire span without encountering anything of significance, without any external force capable of stopping it, or turning it, or breaking it apart. At 1 million years from now, Voyager 1 will have travelled an additional distance of roughly 5.5 light years from where it is today, moving through interstellar space that to any observer watching from Earth would appear completely featureless, cold, silent, moving. The Earth by this point will be a very different place. The continents will have shifted. Mountain ranges that exist today will have eroded significantly. Whether human civilization still exists at 1 million years from now is entirely unknown, entirely open, entirely beyond our ability to guess. But Voyager 1 will still be there, moving through a region of space that has no name and no significance except this, that something built by human hands once passed through it, long ago. When the species that built it was still young and still alive and still capable of wondering what was out there. At 10 million years from now, the sun would be invisible to the naked eye from Voyager 1's position. Just another dim point of light among the hundreds of billions that fill the Milky Way. Indistinguishable, unremarkable, our star, our home, lost in the crowd. And yet Voyager 1 carries something from that invisible star. Sounds and images and greetings and music, a heartbeat, the sound of rain, the song of whales, all of it sealed in gold and copper and aluminum, still travelling, still intact most likely, after all those millions of years. Because in space, without atmosphere or moisture or the ordinary agents of decay, physical objects can survive for an extraordinarily long time. Let that thought drift through your mind like something slow and warm. The weight of millions of years, the patience of stone and space and starlight, and somewhere in all of that immensity, something small and human, still moving, still carrying its message. Your breath is slower now, your body heavier. The story continues at its own pace, and there is no need to follow every word. Let it wash over you. Let the distances carry you somewhere soft and deep and quiet. We are moving through deep time now, and deep time has a texture all its own. There is a motion that most people never think about, a motion that is happening right now, tonight, as you lie still and breathe slowly. It is not the motion of Voyager 1. It is the motion of everything. The solar system is moving through the Milky Way galaxy at roughly 220 kilometers per second, every second of every day. The sun, the earth, the moon, every planet, every asteroid sweeping through the galaxy in a great, slow, curving arc, completing one full orbit of the galaxy approximately every 225 million years. Astronomers call this the galactic year. One orbit of the Milky Way, 225 million years. The last time the solar system was in the same position it occupies today, the dinosaurs did not yet exist. The dominant land animals were the distant ancestors of the creatures that would eventually give rise to them. Trilobites still swam in the ancient oceans. Now, think about what this means for Voyager 1. When Voyager 1 left the solar system, it carried with it the velocity of its launch. But it also carried another velocity, the velocity of the solar system itself. The 220 kilometers per second that everything in our solar neighborhood is moving at as it orbits the galactic center. This means Voyager 1 is not just moving away from the sun in a simple straight line. It is also moving with the galaxy, sweeping through the Milky Way along a trajectory shaped partly by its own launch and partly by the enormous gravitational current of the galaxy itself. Over tens of millions of years, this becomes significant. The stars around us are also moving, each one following its own orbit around the galactic centre, at slightly different speeds, at slightly different angles. Over millions of years, the positions of the stars relative to each other change. The constellations we see tonight will not exist in any recognisable form in 100 million years. At 50 million years from now, Voyager 1's exact position is genuinely unknowable. Small gravitational nudges from countless stellar encounters will have bent its path in ways that compound over time. Small deflections, tiny changes in direction, each one negligible on its own, but accumulating over millions of years into something that makes precise prediction impossible. What we can say is this: Voyager 1 will be somewhere in the Milky Way, moving, intact, in all likelihood, cold, dark, carrying its golden record, surrounded by interstellar space that looks, in its broad character, much as it does today. There is something quietly remarkable about the resilience of physical objects in space. On Earth, nothing lasts 50 million years, not metal, not stone, not bone. The agents of decay are everywhere on a living planet, but in space, without atmosphere or moisture or the constant chemical activity of a living world, a metal object can persist for an extraordinarily long time. The galaxy seen from outside looks like a slow and graceful spiral, arms of stars curving outward from a bright central hub. But from within, it is something more like a river, a current of stars and gas and dust, all moving together in the same broad direction. Voyager 1 is in that river now, moving with it, carried forward by forces far larger than anything that went into its launch. Let that image rest in your mind as your thoughts grow quieter. A river of stars, patient and enormous, and somewhere within it, something very small and very old drifting with the current, not fighting it, not directing itself, simply moving. The river carries everything eventually, and it is in no hurry at all. By the time we reach hundreds of millions of years into the future, the universe begins to look genuinely unfamiliar, not unrecognizable in every detail, but different in ways that accumulate slowly and then, when you look at the full picture, turn out to be profound. Our galaxy is not alone. It belongs to a small group of galaxies called the Local Group. The two largest members are our own Milky Way and the Andromeda Galaxy, a spiral galaxy similar in structure to ours, located approximately 2.5 million light-years away. Right now, tonight, Andromeda is approaching us, moving toward the Milky Way at roughly 110 kilometers per second. And in approximately 4.5 billion years, the two galaxies are expected to collide. Collide is perhaps not quite the right word, because galaxies are mostly empty space. The stars within them are so far apart that when two galaxies pass through each other, the chance of any two stars actually colliding is extremely small. What happens instead is a gravitational dance. The two galaxies distort each other, pull on each other, stretch and warp each other's spiral arms, scatter stars into new orbits. Over hundreds of millions to a few billion years, the two galaxies will pass through each other, separate and then fall back together again, eventually merging into a single larger galaxy. Astronomers sometimes call this future object Milkomeda, elliptical in shape rather than spiral, containing the stars and gas and dark matter of both original galaxies. But over the course of that time, other changes will accumulate. The sun will be aging. Stars are not permanent. They are born from clouds of gas and dust, burn for millions or billions of years, and then die. Our sun has been burning for about 4.5 billion years. It is expected to continue for roughly another 5 billion before it runs out of hydrogen fuel in its core. At that point it will expand dramatically, growing into what astronomers call a red giant, swelling outward to a size that will engulf Mercury and possibly Venus and perhaps even Earth. The inner solar system, as it currently exists, will be destroyed. This will happen in about 5 billion years. Long after Voyager 1 has drifted far beyond any possibility of being affected by it. By the time the Sun begins to die, the spacecraft will be so far away that the Sun's expansion will have no effect on it whatsoever. After the red giant phase, the Sun will shed its outer layers into space, creating a beautiful expanding shell of glowing gas called a planetary nebula. What remains at the centre will be a small, dense, extremely hot object called a white dwarf, a burned-out ember of a star, cooling slowly over billions of years. Voyager 1 will still be moving when all of this happens, still carrying its cargo of human sound and image, drifting through a galaxy that has changed enormously since the day it was launched. This star that sent it on its way will be gone, and yet the spacecraft will persist, moving through the dark, carrying something from a world that no longer exists, like a message in a bottle, floating in an ocean that has itself been transformed out of all recognition, still intact, still travelling, still, in some quiet and unwitnessed way, still here. Let that thought settle gently over you now, like something soft and warm. The universe is patient, the night is quiet, and somewhere out there, something small and human is still moving through the dark, still moving after everything. We have arrived at a threshold, a place in the story where the numbers change character entirely, where millions of years give way to billions, and billions of years is a scale that requires something different from us. Not just patience, something closer to surrender, a willingness to let the mind stop trying to picture everything precisely and simply allow the vastness to be what it is. 1 billion years from now, the Earth is still there, probably. The Sun has not yet reached the dramatic phase of its death. That is still several billion years away. But the Earth at 1 billion years from now is not the Earth we know. The Sun, as it ages, very slowly increases its brightness. It burns slightly more intensely as its core gradually changes its composition. In roughly 1 billion years, it will be shining approximately 10% more intensely than it does today. 10% does not sound like much, but for a planet sitting as close to its star as Earth sits to the Sun, 10% more energy is an enormous amount. Climate models suggest the increased solar energy will begin pushing Earth's surface temperatures beyond the range that supports complex life as we know it. The oceans may begin to evaporate. The conditions that have supported life for billions of years will start to deteriorate. Whether life itself will be gone by 1 billion years from now is genuinely uncertain. Life is remarkably adaptable. Simple organisms have survived conditions that would kill almost anything we're familiar with. But the Earth of oceans and forests and seasons and weather, that Earth will be gone or profoundly changed within the next billion years, and Voyager 1 will know nothing of any of this. At 1 billion years from now, Voyager 1 will be somewhere in the Milky Way, its precise location impossible to calculate, still moving, still intact most likely. The golden record almost certainly still there. Gold is among the most chemically stable of all elements. It does not react with the sparse particles of the interstellar medium. The record itself, sealed within its cover, may still be remarkably well preserved, still carrying its sounds and images from a world that has, by this point, changed beyond all recognition. At 2 billion years from now, the Andromeda collision is well underway. The two galaxies beginning their long gravitational embrace, great streams of stellar material arcing across space, regions of intense new star formation triggered by the compression of gas clouds. The spiral arms of both galaxies pulled apart and reshaped into something new. Voyager 1, drifting through all of this, may be gently affected by the gravitational changes. But the effect on any individual object moving through spaces so empty is likely to be gradual. A slow reshaping of the trajectory over millions of years rather than any sudden change. And at roughly 5 billion years from now, the change begins in earnest. The hydrogen in the Sun's core runs low. The outer layers expand dramatically. Over hundreds of millions of years, the Sun swells outward, growing, reddening. It becomes a red giant. Mercury is engulfed. Venus follows. Whether Earth survives as a physical body is uncertain, but it would be a scorched and airless rock by then, unrecognizable, dead. Voyager 1, somewhere in the galaxy by this point, continues moving, unaware that the star which launched it has died, carrying the sounds of a world that no longer exists around a star that no longer shines. There is no sadness in this exactly. It is simply the nature of time. Stars live and die. Planets change. And yet something persists. Something moves. Something carries the record forward. Let your breathing slow a little more. Let the images settle. The sun growing old and red. The earth changed beyond recognition. And somewhere in the dark between the stars, something still moving. Through a universe that has grown older and quieter and stranger, but has not yet finished its long story. Not yet. Not for a very long time still. Now we must make the largest leap yet. A leap that takes us so far into the future that even the death of the sun begins to seem almost recent by comparison. We are moving now into trillions of years. 1 trillion years. The current age of the universe is roughly 13.8 billion years. 1 trillion is approximately 72 times that. A span of time so enormous that it makes the age of the universe itself seem brief. And yet, 1 trillion years is only 1/10 of the 10 trillion years at the heart of this story. We have only just crossed the entrance to the deepest part of what lies ahead. Physicists have a name for the current era of the universe. They call it the stelliferous era, from the Latin word for stars, the age during which stars form, burn for millions or billions of years, and fill the universe with light and heat and the heavy elements that make planets and life possible. We are in the stelliferous era right now, and it will continue for a very long time, but not forever. The stelliferous era is expected to end somewhere around 100 trillion years from now. Here is why. Stars form from clouds of gas and dust, primarily hydrogen and helium. Every time a star forms and burns, it converts some of that hydrogen into heavier elements. When the star dies, it releases some of those elements back into space, but not all of it. Some mass is locked away permanently in white dwarfs and neutron stars and black holes, objects that no longer participate in the cycle of star formation. Over trillions of years, the available supply of fresh hydrogen gradually decreases. New stars continue to form, but at a slower and slower rate. The universe becomes less efficient at making stars as time passes. The last stars to form will be the smallest. Red dwarfs. Those cool, dim, patient stars that burn their fuel so slowly that they can last for trillions of years. They are the final campfires of the stelliferous era, burning quietly, reddish and faint, in a universe that is growing darker and colder around them. At 1 trillion years from now, most of the stars that exist right now will be gone. The sun will have been dead for over 500 billion years. The brilliant blue and white stars that currently light up the spiral arms of galaxies will have burned out long ago. What remains will be mostly red dwarfs, small, cool, patient, burning with a quietness that dwarfs anything we're used to thinking about. the merged galaxy of Milky Way will have settled into its final elliptical shape. Quieter now, more diffuse, still containing billions of stars but arranged differently. Without the elegant spiral structure that currently makes the Milky Way so beautiful from a distance, Voyager 1 will be somewhere within or near this structure, still moving. The erosion from micrometeorite impacts will have continued for 1 trillion years. Some components will have been damaged, but the fundamental structure, the core body, the golden record in its case, is likely to have survived. Think about what that means. 1 trillion years of travel, 1 trillion years of silent movement through the dark. And the record is still there. These sounds of Earth, sealed in gold and copper, the photographs, the greetings, the music, 1 trillion years old and still in some sense intact. At 10 trillion years, the stelliferous era is drawing toward its close, the last red dwarf still burning, but running low, the universe darker than it has been since the first stars formed, the spaces between the remaining stars vast and cold, the temperature of the universe dropping toward almost nothing. Voyager 1 is still moving. It's been moving for 10 trillion years, drifting through a universe that has transformed from the vibrant star-filled cosmos we know into something older and quieter and more sparse, and still it moves. Let that settle over you now like something very gentle and very heavy at the same time. 10 trillion years of motion. 10 trillion years of carrying something human through a universe that has forgotten, in every practical sense, that humans ever existed. And yet the record is there, and it is still moving. Your breath is slow now, your thoughts are softer. The universe is older than it has ever been in this story. And the night, your night, is quiet and warm and close, still moving, after everything, still moving. The last red dwarf has gone out. Not dramatically, no explosion, no final burst of light, just a gradual dimming, a cooling. The most patient stars, burning so carefully for so many trillions of years, finally exhaust their fuel, one by one, until the last one fades, and the universe enters a new era. Physicists call it the degenerate era, the age after stars, the age in which the universe is no longer lit by the ordinary fire of nuclear fusion. What remains are the cold remnants of what stars once were: white dwarfs, neutron stars, black holes, and the vast, dark, empty spaces between them. This era begins somewhere around 100 trillion years from now. Imagine the universe at that point. The galaxies that once blazed with the light of billions of stars are now dim, not completely dark, not yet. White dwarfs still glow faintly with residual heat, slowly, steadily, radiating that heat away into the surrounding darkness, getting cooler, getting dimmer year by year, trillion by trillion. A white dwarf is essentially the exposed core of a dead star, dense, hot, about the size of the Earth, no longer generating energy through fusion, simply cooling, slowly releasing into space the thermal energy stored in its interior. This cooling process takes an almost incomprehensible amount of time. Eventually they become what theorists call black dwarfs, cold, dark, inert. Between all of these objects, distances that were already enormous have grown larger still. The universe is expanding, driven by dark energy, a property of space itself that causes the universe to grow at an accelerating rate. Over trillions of years, the remnants of galaxies have been pushed further and further apart. The universe is growing emptier, growing darker, growing colder, steadily, with the same patient inevitability that characterizes everything at these timescales. And Voyager 1 is somewhere in all of this, still moving, 10 trillion years of travel behind it. the surfaces of the spacecraft heavily eroded by now. Billions of micrometeorite impacts have pested and scarred every exposed surface. But the core structure, the golden record, these are likely still there. Metal, in the cold and sparse environment of deep space, does not simply dissolve. It persists, and it is still moving. Because nothing in the degenerate era has changed that fundamental fact. There is no friction in space, no resistance. The same laws of physics that set Voyager 1 in motion in 1977 are still operating, unchanged, indifferent to the passage of time. The degenerate era is a quieter universe than anything we have described before tonight. The drama of stellar birth and death has ended. What remains is something more like a long, slow, cooling exhale. Let the quietness of that settle around you. The degenerate era is not a frightening place. It is simply old, profoundly, incomprehensibly old, and somewhere in that darkness, something is still moving. There is a question that physicists have been asking for decades, a question that sits at the edge of what current science can confidently answer. Does ordinary matter last forever? Everything around you is made of matter. The blanket on your body, the walls of the room, your own body, all of it made of atoms, and atoms are made of protons and neutrons and electrons. These particles have been around since the early universe. They have persisted through billions of years of cosmic history. But some theories in physics suggest that protons are not perfectly stable, that over an extremely long period of time, individual protons may spontaneously decay, break down into lighter particles, transforming into energy and leaving behind nothing that constitutes ordinary matter. The predicted timescale is genuinely staggering. Current constraints suggest that if protons decay, their half-life must be at least around 10 to the 34th years, A1 followed by 34 zeros, a number so large that our entire story tonight looks like a rounding error in comparison. It is important to say clearly that proton decay has not been observed. Physicists have built enormous detectors deep underground specifically to watch for it. So far, none has been detected. It may simply mean the timescale is even longer than current theories predict. But if proton decay does occur, the implications are profound. It means the atoms that make up Voyager 1 will eventually dissolve. The gold of the record, the aluminum of its cover, the titanium of the spacecraft's structure, all of it, atom by atom, proton by proton, until there is nothing left except faint flickers of radiation spreading outward into a cold and empty universe. The golden record would go the same way. The sounds of Earth, the greetings in 55 languages, the music of Bach and Beethoven, the heartbeat, all of it eventually dissolving into nothing. Not because of impact or heat, but because the very particles of which matter is composed would cease to hold together. And yet, even if this happens exactly as some theories predict, the timescale is so enormous that Voyager 1 will have been travelling for longer than the current age of the universe, multiplied by millions before the first atom begins to dissolve. Before that end, Voyager 1 will have drifted through a universe that was once filled with hundreds of billions of galaxies and trillions of stars. That produced, on at least one small planet, something that looked up at the sky and wondered, and then built something and sent it out. The spacecraft will have outlasted all of that. By margins we do not have words for. Let that rest in the quiet of this night. The universe is generous with time, extraordinarily generous, and Voyager 1, that small and ordinary machine built by ordinary people, has been given a journey so long that the mind cannot fully hold it. It simply moves, it simply persists, carrying its cargo of human sound and image through a darkness deeper than anything the people who built it ever imagined. And in this moment, Right now, it is out there, still real, still part of the same universe you're lying in tonight. Let yourself rest now, gently. The story has a little further to go. We have passed through the degenerate era now, through the long, slow cooling of white dwarfs, through a universe that grew darker and emptier with every passing trillion years, and we've arrived somewhere new. Physicists call it the black hole era. Almost everything that was once recognizable as structure in the universe has disappeared. The stars are gone. The white dwarfs have cooled to black dwarfs, invisible and inert. The neutron stars have slowly lost their rotation and their magnetic fields, becoming cold and dark, and what remains are the only structures that still hold together with any significance. Black holes. They are the dominant features of what remains, not because they fill all of space. The universe is still mostly empty, but because everything else that once provided structure has faded, leaving black holes as the last gravitationally significant objects in existence. A black hole is a region of space where matter has been compressed to such extreme density that nothing, including light, can escape beyond a certain boundary. The event horizon. They do not pull matter in from arbitrary distances. They are only felt up close, within the region where escape becomes impossible. But over extraordinarily long timescales, black holes do accumulate mass, slowly, patiently, absorbing whatever sparse material drifts close enough to fall in, occasionally merging with other black holes, growing, becoming the universe's final concentrations of organized energy and matter. Voyager 1 moves through all of this, still drifting, still following the trajectory that the laws of physics assigned it so many trillions of years ago, far from any black hole in all probability. The universe is so large that the chance of drifting close enough to be significantly affected is small, but not zero. It is possible that at some point during the black hole era, Voyager 1's long drift will carry it into the gravitational influence of one of these ancient remnants. The gravitational pull, felt from a sufficient distance, will begin to curve the spacecraft's trajectory, slowly, gradually, pulling it into a long, slow spiral inward. If that happens, the end of Voyager 1's physical journey would be unlike anything else in this story. Not a collision, not an explosion. A slow, gentle, inexorable drift, taking millions of years to complete. The tidal forces growing stronger as the distance decreases, eventually stretching and distorting the spacecraft into a long, thin stream. Physicists have a name for this process, both precise and almost poetic in its way. They call it spaghettification. Whether this is how Voyager 1's journey ends is unknown. It depends on where the spacecraft ends up after trillions of years of gravitational drift. But there is another possibility, a more beautiful one. First described by the physicist Stephen Hawking in the 1970s, it is called Hawking radiation. Near the event horizon of a black hole, quantum mechanics allows pairs of particles to be created. One falls across the horizon, the other escapes. To a distant observer, this looks like the black hole is slowly radiating energy, and because energy is equivalent to mass, the black hole loses a tiny amount of mass with each radiated particle. Supermassive black holes radiate so slowly that the process is almost inconceivably gradual. But it is relentless, and it has only one end point. Eventually, every black hole in the universe will evaporate, will release its final burst of energy into the cold dark, and then cease to exist. The black hole era ends not with a collapse, but with a long sequence of very quiet endings, one by one. Let your thoughts grow quieter now. The black hole era is long and dark and still, just the slow, ancient processes of a universe winding down. And somewhere in that darkness, something is still moving, We're approaching the end now, not the end of the universe, but the end of what can be told about Voyager 1 within any framework that current physics can describe. And before we arrive there is a question worth sitting with. A question that the entire journey of Voyager 1 quietly asks without ever being able to answer. Will anything remain? The golden record is the heart of this question. It was placed on Voyager 1 with a specific intention, not just to travel, but to communicate, to carry something from one kind of mind to another, to reach across whatever distances and differences might separate the civilization that sent it from any civilization that might someday find it. That intention is still there, sealed in gold, drifting through the dark. By the black hole era, the odds of anyone finding it are essentially impossible to calculate, not because they are zero, but because we have no framework for imagining what, if anything, exists in a universe this old. Whether intelligence in any form persists across these timescales is entirely unknown. The conditions that produced life on Earth required certain things: liquid water, a stable energy source, complex chemistry. In the black hole era, those conditions are almost certainly not present anywhere in the universe, and yet, the golden record was sent into that uncertainty, deliberately, knowingly. The people who made it understood they could not predict who or what might find it, and they sent it anyway, with greetings, with music, with the sound of rain and the calls of whales and a human heartbeat. There is a particular kind of courage in that. The courage to send something out without knowing whether it will ever be received, simply trusting that the act of reaching outward has value, regardless of outcome. Voyager 1 is the physical embodiment of that courage, a spacecraft built by people who knew they would never see where it ended up, carrying a record made by people who knew the odds of it being found were vanishingly small, sent out into a universe so large that the gesture might seem almost absurd when measured against the distances involved. And yet here we are, tonight, talking about it, following its journey, feeling something when we hold the image of it moving silently through the dark, something that is hard to name precisely, but that feels like it matters. That feeling is real. Whatever else is uncertain about the deep future of the universe, that feeling, tonight, in you, is real. The universe does not require witnesses to continue its story. The black holes do not need an audience to evaporate. The last light does not need eyes to receive it. But we are witnesses, right now, tonight, to something extraordinary. To a small machine that has already been travelling for decades and will continue travelling for longer than the mind can hold. To a record sealed in gold and sent out into the dark. Let your body be very still now. Let your breath be very slow. The universe outside is patient and enormous, and full of a darkness that is not frightening, just deep, just old. And somewhere out there, something human is still moving through the dark, still reaching, still carrying something forward, into a night that has no end and no edge and no destination, just motion, just the quiet, ancient, unstoppable motion of everything that was ever set in motion by anything. Something has changed. Not suddenly. Nothing in this story has ever changed suddenly. But somewhere in the unimaginable depths of time that follow the black hole era, something has shifted. Something has ended. The last black hole has evaporated. It happened slowly. The final black hole, the most massive remnant of the most massive galaxy cluster in the observable universe, radiated away its last particle of Hawking radiation over a span of time measured in numbers that have no conventional name. It shrank, degree by degree, until it reached a final burst of energy, a last flash of radiation spreading outward into the surrounding dark, and then nothing, No more black holes, no more white dwarfs, no more neutron stars, no more planets. Even the sparse particles that once constituted the interstellar medium have, if proton decay operates as some theories predict, long since dissolved into lighter particles and energy. What remains is this: a vast, cold, expanding space, filled with an extraordinarily thin soup of the lightest particles that physics allows to exist. Electrons and positrons drifting alone through distances so enormous that the chance of any two of them ever meeting is almost zero. Photons spreading outward from the last events that produced them, their wavelength stretched by expansion into something so long and so faint they barely qualify as light. The temperature of the universe is so close to absolute zero that the difference is almost philosophical. Not quite zero, but so close that the distinction matters only in theory. This is sometimes called the heat death of the universe, not because it is hot, precisely the opposite. All available energy has been distributed as evenly as possible throughout the expanding space. No more temperature gradients, no more engines, no more chemistry, no more anything that requires a difference in energy between one place and another. The universe has reached a state of maximum entropy, a state in which nothing further can happen. This is not a violent ending. It is simply the final chapter of a very long story. A story that began in an almost incomprehensibly hot and dense state 14 billion years ago. That produced, on at least one small world, beings who looked up and wondered and built machines and sent them outward. And somewhere in this ultimate darkness, if proton decay has not yet completed its work, there may still be something drifting, something very small, very cold, very old, moving at 60,000 kilometers per hour through a space that contains almost nothing, carrying a golden record that no one will ever find, moving through a universe that has forgotten, in every physical and energetic sense, that it ever contained anything as remarkable as a star. Let the darkness be peaceful, let it be soft. It is not the darkness of fear or loss, it is the darkness of completion, of something that has run its full course. And still, somewhere, motion, still, somewhere, a small metal thing drifting through the last emptiness, still carrying its record, still moving forward, into the final quiet. There comes a point in any long journey where the destination matters less than what the journey itself has revealed. We have followed Voyager 1 from a September morning in 1977 to the edges of physical reality, through the death of the sun, through the merger of galaxies, through the slow cooling of white dwarfs, through the evaporation of black holes, through the final dispersal of matter into a universe that has given everything it had to give. And now it seems right to pause, to ask not what happens next, but what any of it means. Voyager 1 was built by ordinary human beings, engineers and scientists and technicians, people who had families and favourite foods and days when the work went badly, people who argued about technical decisions and felt proud when something worked. These people built something. They launched it into space and tracked it as it travelled and listened to its signals as it crossed the outer solar system. They did all of this knowing that Voyager 1 would outlast them, that it would outlast their children and their grandchildren and every generation that might remember their names. They built it anyway. They put the golden record on it anyway. That act, that simple, human, almost defiant act of making something and sending it out into the unknown, knowing it would outlast you, knowing it might never be found, knowing the universe is under no obligation to receive or acknowledge what you have sent. That act is one of the most extraordinary things our species has ever done, not because of what Voyager 1 will achieve, but because of what it says about the kind of creature that built it. a creature that looks at an enormous and indifferent universe and decides to reach into it anyway. To say, in effect, we were here, we existed. We thought and felt and made music and wondered about the stars, and we wanted you to know. Voyager 1 carries all of that, literally. The Golden Record is a physical artifact of human consciousness, of human feeling, of the human desire to connect, travelling through a universe that has no requirement for any of those things. Think about that tonight, as your body grows heavier and your thoughts grow softer. Something built by human hands, carrying human music and human voices and the sound of human rain, moving through a universe so large that no number we have words for can adequately describe it, not arriving anywhere, not achieving any particular goal, just moving, just persisting, just carrying the record forward. There is a kind of faith in that, a trust that the act of reaching out has value even without a guaranteed response, that making the gesture matters even if the gesture goes unwitnessed. And tonight, while you rest, Voyager 1 is out there, still moving, still carrying its record, still part of the same universe you're part of. Something went out from here, from people like you, into the night, and it is still out there, moving, carrying the record, in the same night that surrounds you now. There is a quality that deep time has, a quality that becomes clearer the further into it you travel. Not bleakness, something softer than that, something closer to what you might call release. Everything that exists in the universe is, at some level, temporary. A wave on the surface of water is temporary. A cloud is temporary. A mountain is temporary on long enough timescales. A star, a galaxy, a universe. All of these things arise from conditions that allow them to arise. They persist for as long as those conditions hold, and then gradually they change into something else. Nothing is destroyed in any absolute sense. Energy is conserved. What happens to matter over very long timescales is not annihilation. It is transformation, a return to simpler, more dispersed forms. The atoms that make up your body right now were forged in the cores of stars that exploded before the sun was born. You are, in a very literal sense, made of stardust, made of the transformed remnants of things that came before you. Voyager 1 is also made of those remnants, aluminum and titanium and copper and gold, all of it forged in stellar cores, all of it assembled by human hands into a specific shape with a specific purpose, and all of it eventually returning to whatever the universe holds in its final state. But for now, for this long, almost inconceivable stretch of time, Voyager 1 carries something forward, not because the universe requires it, not because anyone is watching, simply because it is moving, and nothing has stopped it yet. There is a concept in physics called momentum, the tendency of a moving object to continue moving. In the absence of any force acting against it, an object in motion stays in motion. Motion, once begun, persists. It does not require ongoing effort to maintain, it simply is. Voyager 1's momentum was given to it on September the 5th, 1977, by a rocket, by fuel burned in a few minutes of intense combustion, by human intention and engineering and effort, and then released into a universe that offers no resistance to its continuation. Think about the people who built it. Most of them are no longer alive. Their names are in records, their work documented in technical papers and mission logs. But their most lasting contribution is not in any document. It is in the motion itself, in the momentum they gave to this small machine. That momentum is still theirs, still carrying forward the intention they encoded into it. In this way, Voyager 1 is a kind of memorial, not one deliberately designed as such, just one that became, through the passage of time, the most durable monument to human existence ever created. More durable than any pyramid, more durable than any carved stone or written manuscript. Moving silently through a universe that will outlast all of those things by margins so large that the comparisons feel almost silly. Let it go. Those 3 words have a particular resonance tonight. As your body grows heavier, as the thoughts that were still moving begin to slow and drift apart like clouds on a still evening, Voyager 1 was let go, released into the universe, not held on to, not called back, let go, into the dark, into the distance, into a future that no one can see, and in its going, it became something larger than itself, a gesture, a human gesture, aimed at the universe itself. There is something that happens when you spend time with very large numbers, very long stretches of time. Something shifts. The mind resists scale. It is built for human distances, human time scales, the distance between 2 villages, the length of a human life, the span of a few generations. These are the scales our brains are calibrated for. The cosmic scale is not built into us. We have to reach for it, deliberately, one step at a time, the way we have been doing tonight. And when we do reach for it, something unexpected sometimes happens. The ordinary concerns of the day begin to feel lighter, not insignificant, never insignificant, but lighter, more proportionate, held within a context that gives them a different character. The universe does not know about your deadlines, about the conversation that went badly, about the worry that has been sitting in the back of your mind for the past few days, about the tiredness that has been accumulating for longer than you would like to admit. The universe does not know, and somehow, knowing that it does not know is paradoxically a relief. Not because those things do not matter. They do matter. Your life matters. Your struggles matter. But they are happening inside a universe that is 14 billion years old and filled with hundreds of billions of galaxies, each containing hundreds of billions of stars. And somewhere in that universe, a small spacecraft is drifting through interstellar space carrying the sound of whale song and a human heartbeat. Carl Sagan wrote about this often. He described the view of Earth from space as a pale blue dot, a mote of dust suspended in a sunbeam, and he argued that this view contains within it a kind of gift, the gift of proportion, of seeing our world and our lives within their actual context, not to diminish them, but to love them more clearly, because the universe is large and old and patient. And yet here we are, on this particular dot, with these particular lives, with the capacity to wonder about things that have nothing to do with our immediate survival. That capacity is extraordinary. The universe contains, as far as we know, one place where something looks back at it and asks questions. One tiny blue world, one species, one moment in cosmic history. And in that moment we built Voyager 1, we sent it out, we listened for as long as we could. You are here, right now, part of this, part of something so much larger than you can hold, and yet genuinely, really, actually part of it. Let that be the feeling that carries you now. Not the distances, not the numbers, just this. You are here, in the universe, on a warm night, with your body resting and your mind growing soft. The thoughts that were moving are slowing now, one by one, like lights going out in the windows of a city settling into night. The breath is slow, the body is heavy, the night is soft. Something is still moving out there. You can let it move without following it. Let the dark be the dark. Let the universe be as large as it is, and rest here, in the small and warm and real. Just rest. We have travelled a long way tonight. Not just through space, through time, through scales of distance and duration that the human mind was not built to hold comfortably. And yet here you are, still breathing, still present in this warm and quiet place while the universe outside continues its patient and enormous work. There is something worth noticing about that. The vastness does not make this moment smaller. It makes it more precise, more specific, more real in a particular way that is difficult to describe but that most people recognize when they feel it. The feeling of being genuinely located, of being somewhere real, of being this person in this place, on this night. The universe is large, and you are small within it. And that is exactly fine. That is the ordinary condition of every conscious being that has ever existed on this planet. Every person who ever looked up at the night sky and felt the strangeness of being a small, aware thing in a large, unaware cosmos. All of them small, all of them here, all of them briefly and specifically present in a universe that goes on without them, and yet is shaped in small ways by the fact that they were here at all. Voyager 1 is shaped by the people who built it. It carries their intentions, their choices, their care, their desire to reach out and say something to whatever might be listening. That shaping is real. It persists. It will persist for longer than almost anything else those people ever touched. The night sky has always done this for certain people. Long before telescopes, long before space probes, people lay down in the dark and looked up and felt something. Not fear, not always. Sometimes something quieter, a sense of proportion, a sense of being part of something that mattered, even if the exact nature of that mattering was unclear. That sense is available to you tonight, right now, without moving, without doing anything at all. Just the knowledge that above you, beyond the ceiling and the clouds and the atmosphere, the universe is there, as it always is, patient and enormous, and among those objects, moving silently through interstellar space, a small golden-covered record, carrying the sounds of this planet, still travelling, still real. The room is quiet, your body is settled, the thoughts that were moving have mostly stilled. The breath rises slowly and falls and rises again. Somewhere very far away something is moving through the dark, carrying a record of everything that felt worth saving from this small and extraordinary world, and here, close, warm, safe, something is settling toward rest. Both things are true at the same time, the vastness and the nearness, the enormous distance and the quiet room, both real, both present, both part of the same story. Let the story hold you now, gently, without effort, the way water holds something that floats, without gripping, without effort, just the natural support of something larger, receiving something smaller and carrying it forward. You do not need to do anything else tonight. The universe will continue its work without your supervision. Voyager 1 will continue its journey without your attention, and you can rest fully, completely, into the quiet. The mind, as it approaches sleep, does something interesting. It loosens its grip on the ordinary, on the specific details and demands of the waking day, on the names and faces and tasks and worries that occupy it during the hours of alertness. It begins to release these things, one by one, in a slow dissolving that is one of the most natural and necessary processes a human being undergoes. Tonight, the images that have been floating closest to the surface are large and slow and dark in the most peaceful sense of that word. A spacecraft, small and golden covered, moving through a darkness so complete that the nearest star is measured in light years. A golden disk, sealed in aluminum, carrying sounds that began on a living planet and are now travelling through the dead silence of interstellar space. A universe growing older, growing quieter, growing darker, with the same patient inevitability that a night deepens as the hours pass. These images do not need to be thought about now. They do not require analysis or understanding. They can simply be present, the way a landscape is present outside a window, there, real, not demanding anything. You're also in motion, in a sense, even in rest. The earth beneath you is turning, the solar system is sweeping through, the galaxy. The galaxy itself is moving. Everything is travelling, everything is going somewhere, even when it does not feel that way. Rest is not the absence of motion, it is motion at the right scale, at the scale of breath, of heartbeat, of the slow cycling of thought that continues even in sleep, of the body doing its quiet restorative work in the dark. You have something Voyager 1 does not, something that makes you, in a particular way, more remarkable than the spacecraft, not more durable, not more far-travelling, but more alive, more capable of the full range of what existence can be, including this, the ability to lie still, to breathe slowly, to let the day go, to receive the quiet gift of sleep. That gift is available to you now, fully, completely, without condition. The body knows what to do. It has done this every night of your life. It will do it now, naturally, gently, without effort on your part. The breath is slow. The body is heavy in the best possible way. The mind is soft at its edges. The universe is very large, and very old, and very patient. And somewhere in it, something is moving through the dark with a golden record and no destination and no urgency. And here, small and warm and present, something is settling into the deep rest that a long and wondering mind has earned. The last thought before sleep can be anything, or no thought at all. Just the breath, just the weight, just the darkness behind the eyes that is not the darkness of space, but the darkness of rest, warm and close and held. The spacecraft moves, the universe breathes, the night deepens, and you sleep, slowly, gently, completely, into the quiet that waits at the end of every long journey, right here, right now. Sleep. You are still here. Maybe you made it all the way through. Maybe you drifted off somewhere in the middle and came back. Maybe this is the first moment you're actually hearing clearly, emerging slowly from the soft edge of sleep into something like waking attention again. All of that is exactly right. All of it is exactly what this kind of story is for. Tonight we followed something small through something enormous. We started in 1977 on a Florida launch pad, with a rocket and a spacecraft and a golden record and a group of human beings who wanted to reach out into the unknown and say something true about who they were. We watched that spacecraft leave the solar system, drift through the galaxy over millions of years, persist through the death of the sun and the merger of galaxies and the slow cooling of the last stars. We followed it into a universe so old and so dark and so quiet that the word universe barely feels adequate anymore. And through all of it, that small spacecraft kept moving, kept carrying its record, kept being real. Voyager 1 is out there right now, not as a story or an image, as a physical object, moving through interstellar space at 60,000 kilometers per hour. More than 23 billion kilometers from the sun, carrying its golden record, sending its faint signal back across the void toward the antenna dishes that are still, right now, listening. It will be out there tomorrow, and next year, and in 100 years, and in ways that stretch this story to its very limits, for a span of time that makes all of human history seem like a single quiet breath. The people who built it are mostly gone now, but the thing they built is still going, still carrying what they put on it, still moving through the dark with the intention they gave it. Something built with care and intention persists. Something sent out with the desire to connect reaches further than anyone who sent it could have imagined. If this story gave you something tonight, if it carried you somewhere softer than where you started, somewhere where the ordinary weights of the day felt slightly lighter for a little while, then it did what it was made to do, and if you want more of this. More quiet journeys through big ideas, more late nights following something small through something enormous. Then there are a few small things you can do that make a real difference. Leave a like if this helped you rest. It takes a single second, and it helps more people find their way to this kind of story on the nights when they need it. Subscribe if you want to be here for the next journey, the next spacecraft, the next quiet late-night exploration of something that stretches further than the eye can see, and leave a comment. Tell us where you're listening from tonight. What city? What country? What corner of this small blue planet? A bedroom in Tokyo? A late night in Sao Paulo? A quiet house in the English countryside? Wherever you are part of this, part of the same universe as Voyager 1, made of the same atoms, moving through the same space. Sleep well, rest deeply, and whenever the world feels too close and too loud and too urgent, remember that above you, always above you, there is a universe so large and so old and so patient that your most pressing worry fits inside it like a single grain of sand fits inside an ocean. And somewhere in that ocean, moving quietly, carrying its music, something small and human, still out there, still going. Good night.